Okay, as soon as we have started the recording, please inform me. And remember, I can no longer see your screen. So you cannot give me a thumbs up. Someone should unmute and say, yes, I can see it's recording. And then we proceed. As soon as you can see that we are recording, please inform me.
Yes, it's recording.
Hey, thanks. So let's quickly dive into this question. And there's many other questions which we can do if you do have them. And once again, please remember to admit your classmates. That's rule number 1. And then number 2, please unmute yourself if you are not understanding of what I'm doing. I'm more than happy to explain again and again to you. So let's have a look at this problem which one of you shared. And the problem reads, a belt connects pulleys of radius r, which is 5, and big radius r, which is 20. With centers, x is 30 centimeters apart. So the centers are 30 centimeters apart. And then they're saying find the length of the belt. And so let's see, find the length of the belt and the area enclosed by it. So if you look at what is going on here, the length which they are speaking about is length L, which is the distance from which I will make to be read. We need to figure out how long is that belt. So the length we are looking for is what will be in red. From there until here. So we're looking for that length. Something here. Let's put it back. So that's the length which we are looking for, which is L. And then they are saying we are looking for the area which has been enclosed by the belt, which means the area they are speaking about is this area, the one which I will shade in blue. They are saying they want all that area which has been enclosed by the belt. So we need to figure out what that area is, which is in blue. Okay, and finding this area which is in blue is very easy. So that area there, which is in blue, we'll call it A. So there's a couple of things which I want to remind you before we go into this, which will help you to understand the problem. And the first thing I would like to remind you is that when we find ourselves with a sector, so I'll say to you, remember, so that when we do this problem, life becomes easy. And what I want you to remember is that if we have a sector, let's say we have a sector like that, and then this sector is angle theta, and from here to there, the length is radius r. What we should remember is that the arc length from there to there, the arc length, which we will denote as S. If you remember from your work, that arc length there, which is S, it will simply be given by our R multiplied by our theta, where our theta, which is the angle, should be in radians. So that's one thing we should remember. Our S here is the arc length. So which means if we are given an angle of a sector, we can easily find the arc length. So I need you to remember this. It's very important. And then what we need to remember also is the area. So this would be arc length. And then if you remember, we need to also look at the area because they are saying we need to find the area. And we need to remember the area of a sector. And the area of a sector like this one would be half of the radius squared multiplied by theta, which is that angle there. AP. So let's quickly try and figure out what the L is going to be. So what I'm going to do here is I'm going to look at this in small sectors. Let's copy that and paste it this side. So you should look at my equations, which I gave you here. So if you look at the small s here, this one, that sector there is the arc length of that small circle. And we said the arc length of any sector will be given by, so that one is sector 1. So we'll call it S1. Let me make it to be purple so that we see what is going on. If you look at the previous page, we said the arc length is always given by the radius. Someone is their mic not muted. Please check. Just look at your screen and look at where there's a mic and unmute, or mute yourself, sorry. So we can only unmute when we're asking a question, okay? Please. So if you look at our equation here, we said the arc length, which is the length of that line on the outer side, is given by the radius multiplied by the angle. So if we zoom in and look at our S1, you will see that the arc length of S1 is given by our, someone is their mic not muted. Let me quickly check that. Please, good people, let's mute ourselves unless we are asking questions, okay? It's good that we do so. Let me do this first, and then I'll quickly come and check who is their mic not muted. So please make sure that you are all muted. Okay, hopefully I didn't mute myself. Please give me a thumbs up if you can hear me. Okay, my apologies. So please, classmates, let's make the session to be productive. We shouldn't mute or unmute ourselves unless we have questions, okay? Let's do exactly that. So they said, if you look carefully here, the radius of the small circle is 5 centimeters. So meaning the radius from there to here, that is 5 centimeters. And the arc length formula says multiply the radius by the angle and you will be sorted. So, which means our S1 there will simply be our radius, which is 5 centimeter, multiplied by our angle, which is theta 1. We will figure out what theta 1 is after some time, do not worry. So our S1 will simply be that 5 centimeter, I'll call it 5 theta 1, and then I'll put in the length will just be in centimeters. So let's just leave it. So that will be 5 theta 1. And then let's quickly have a look. So we now have that part, which is purple, it's sorted. Now what we need to figure out is this part here, which is blue, because the length of the belt is the blue part, the purple part, and the black part. So we need to figure out what is that distance there. But before we go there, let's go and figure out the arc length here, which is the green part. So if you look at the green parts, it's easy to find, which is the arc length, which we will call S3. So if you look at S3, we said arc length is the radius times the angle. So if you look at the radius from here to here, they gave us. If you look at the problem statement, they said it is 20 centimeters. So what that means is that our S3 will simply be our 20 multiplied by the angle, which we see there, which is O2. So we'll just say 20 O 20 theta 2. That would be our S3 section. And then what is left now is this portion here, which is that L. So we need to figure out what that L is. And anyone in the meeting who has any thoughts of what the L could be? X is 30 meters apart. Okay. So let's quickly dive into what the L is. So if you remember, the radius of the bigger circle is 30 centimeters. So meaning we have 30 cm here, like that. And then even from there to there, we have 30 cm, as you can see. And then the smaller circle, they said it is 5 centimeters, which I will just call 5. And we are now trying to figure out what is that length, which is L. And what we need to remember is that from high school, this is the radius. The radius is always perpendicular to the tangent. So the tangent to the circle will meet the radius at an angle of 90 degrees. But then the question then comes, yes.
The radius is 20 centimeters, not 30 for the big circle.
Let's quickly read the statement. So the radius is 20 centimeters. The distance from the centers is 30. Okay, let's quickly fix that. So the radius is 20. Please be careful. Thanks. The radius is 20, and then from one end of the distance from the two centers is the one which is 30. So this becomes even easier. So meaning from here to here, that distance there is 30. So do you see that this then becomes very easy? Because we can easily calculate that length there. And how are we going to do that? Anyone who has a suggestion?
We can use the theorem of Pythagoras.
When we use the theorem of Pythagoras, what exactly are we finding?
We will be finding the length because we are given the radius is 20 for the bigger circle, right? And then we have the distance between the centers, which is 30. So if we subtract that 5 from 20, we will get the other length so that we can calculate L.
On point. So if you look carefully, the length here, this here, we know that it is 5, isn't it? So since this is a rectangle, it means the length here is still 5. So it means the length, if the total length is 20, it means the length from here to there is 15. Okay, now we have a triangle there. Do you all understand what we did there? So we now have a triangle which looks like this. It has a 90, and then it is a 15 here, and then we have L here, and then we have 30 here. And what we are trying to figure out is that L. So if you remember by the theorem of Pythagoras, we'll have our L squared plus 15 squared equaling 30 squared. So if you quickly transpose, you will see that our L squared will simply be 30 minus 15 all squared. And then our L will simply be the square root of 30 squared minus 15 squared. What is going to be the L here? Anyone? What is 30 squared minus 15 squared?
It's 675.
It becomes, and the square root will be what?
15 root 3.
Square root will be 15 root 3. So this is our L, meaning we are very close to finding the length of the belt because we now have our L. What is left now is to figure out what is this S2, or at least its value, and then also figure out the value of S1. So we only need those angles now, and then we are done. So now the question is, how can we find that angle of theta 2? So we know that we need theta 2 to find the arc length, which would be S2, and we need theta 1 to find the arc length, which would be S1. So if you look carefully, we have a theta here as an angle. And if you look at theta, our theta there plus our theta 2 should give us what?
180.
Should give us 108. But since we're working in radians, we'll put in pi. So how can we solve for this theta from this diagram, and then which will help us to find theta 2? Anyone, how can we solve for theta from this?
We can
Here?
use ratios.
Can you please repeat?
We can use trig ratios.
On point. So we can use cos of theta, because relative to the angle, this is the adjacent. So that would be 15 over, this would be the hypotenuse 30. So cos of theta is 1 over 2. So the question to you all is, it is cos of what, which will give us a half? Remember your special triangles.
Pi over 3.
Okay, let me quickly draw it for someone in case they might have forgotten. Let's make some space here and quickly draw the special triangle for you. So it looks like this. So you have that. And then if you remember, we have pi over 2 here, pi over 6, pi over 3, we have 1, 2, square root 3. So if you look at what is going on here, it is only cos of pi over 3, which will give you a half. So our answer is pi over 3. So we now have our angle, which is pi over 3, which was theta. But we know that for us to get our final answer, we need theta 2, not this theta. So we can go and figure out what theta 2 is. As you can see, our theta 2 plus theta should give us pi. So which means our theta 2 should be pi minus theta, which means pi minus pi over 3. And if you compute this, you will get 2 pi over 3. Do we agree? Okay, so since we now have theta 2, we can now go and figure out what the answer is. But look at what is beautiful about knowing theta 2. Let's look at these lines here. Since we have a rectangle, what can we say when we look at the line I'm drawing and we look at that line which I'm drawing? What can we say about theta 1 and theta 2 or theta? What can we say about theta 1 looking at this diagram which I've drawn here?
The angles are corresponding, they are equal due to parallel lines.
Is corresponding to which angle, theta or theta 2?
Theta 1 is equal to theta.
Okay, on point. So if you look at our diagram there, you'll see that our theta 1 will be equal to theta. What is the reason? I think this we did back in grade 8. What is the reason? Anyone?
Corresponding angles are equal.
Corresponding angles on point. So which means this theta here is the same as pi over 3. So now that we have our S1, S2, and we have our L, we can now find the length of the belt, which is what we made to be red. That's the whole length of the belt. So let's go to the next page and wrap this up. So if you remember, our S1 was 5 theta 1, our S2 was, let me quickly see, our S2 was 20 theta 2, and then our L, we find out to be 15 square root 3. And our theta 1, we just saw now that it is pi over 3. And our theta 2, we saw that it is 2 pi over 3. So the length of the belt is equal to S1, which is 5 multiplied by 3, plus our S2, which is 20 multiplied by 2 pi over 3, and then plus 15 square root 3. So our length of our belt will simply be, if you try to add up all of these, it will be our 5 pi over 3 plus, that will be 40 pi over 3, and then plus 15 square root 3. You can leave your answer looking in this way. There is no need for you to try and simplify. Anyone who has a question, please ask. So we had to find this here as 2, 5, S1, find the L, and then combine, they will give us the length of the belt, which is in red. Anyone who has a question? Okay, and this was all centered around you remembering two things: the length or the arc length of a sector and also the area of a sector. So let's go ahead and compute the area which is enclosed by the belt. Essentially, it's the blue area. So what we can do here, we can be genius about this and say, let's split this into different areas. So let's see how we can do that. So we can call this portion area 1, and we can call this portion here area 2, and then we can call the rectangle portion area 3. And if you look carefully, there's only one thing which is left now, which would be that small portion, which would be area 4. Do you all understand that all these areas will give us the total area? So let me shade these areas differently. Let's come here and erase that, so you'll see what I mean. So we'll find this area here, which we will call area 1, because we're looking for the total area. So that will be classified as area 1. Because we know that that's a sector, we can easily find it. And then we'll take the rectangle and make it to be area 3. It's easy to find the area of a rectangle. We know the length of the side, we know L. And then we will have area 4, or our area 2 rather, which will be all of that. And then we will have the last portion of our area, which would be area 4, which will just be that portion. Very smart. Okay, so let's go ahead and calculate the area for area 1. So if you remember the area of a sector, it is half the radius squared multiplied by the angle. So this means that our area 1, let's see if this thing will copy with my colors. Okay, not so smart. Let's go here. So if you look carefully, our area 1, let's start there and quickly do our area 1. So our area 1, which would be in blue, will be, if you remember, the area is given by half the radius squared times the angle. So if we're looking at area 1, you will remember that the radius is what? 20. You remember, because we have 20 as the radius of the bigger circle. Then we'll square it. The angle A2 or theta 2, you saw that we found it as 2 pi over 3. So 20 squared will be 400. So we have 400 over 2 multiplied by 2 pi over 3. So if you look at area 1, it will simply be, those will cancel. It will simply be 400 pi over 3. That would be some centimeters squared. Do we have anyone who has a question? That would be area 1. Let's quickly dive into area 2 because it is easy to figure out. I'll just rename them. So let's say what is in pink there is my area 2. So if you remember, the area is always given by half the radius squared multiplied by theta for a sector, which is what we have there. It's just a portion of a circle. So our area 2 will be half of, if you remember the radius of that sector, which is pink, which we call area 2, the radius was 5. And then the angle, theta 1, if you remember, we figured out previously that it is corresponding to theta, which was pi over 3. So the angle there will end up being 25 pi over 6. This would be centimeters squared. So we're done with the pink area. Let's now go for the rectangle, because we want to find the area which is covered by that belt. You will see how all of it will combine. In that area, the rectangle will call A3. So if you look at A3, we already have this L here. We found that the L is 15 square root 3. But already we know this side here. That side, we know that it is the radius, which is 5 centimeters. So we now have the length and the breadth of a triangle.
Sir,
Yes.
I have a question. I've been raising my hand for quite a long time now. So
Yes.
The belt, is it covering the upper part, or is it going? Is it circling the entire part there?
The way the belt is shaded here, it appears like it's covering the upper part. You look. You see the boldness is not the same with the one which is below.
Okay.
Yes. So that's what we are working on, because if you can see the boldness is not the same. So we'll just assume it's covering the top part. And then if we look at A3, so please, if you have a question, ask, because I cannot see the screen. If I split the screen to look at your screen, you will have difficulty seeing what I'm writing here. So let's have a look at A3. So if you look at A3, it is a rectangle, which we know from long time ago. We know the rectangle from what, 5 years ago. And the area of a rectangle, you know, it will be just its length, which in this case will be 15 root 3, and then we'll multiply by that radius, which will be height, which will be a 5. So I don't know what this will be. Please help me. 15 square root 3 times 5. So what is 15 times 5? 15 times 4 should be 5. 8 on point. So this is 75 square root 3 centimeters squared. Now we are left with the last part of the area so that we add all these areas and find our answer. So we'll shade that in yellow. That's our area, which we will call A4. And this, good people, we've been doing for the longest of time. So let's quickly see what is going on. We said that part there is 5 centimeters. But the whole length from there to there is 20 centimeters. So that means from there to here, it is just 15. And guess what? We have that, and then we also have the L as the base there. So you remember how to find the area of a triangle. Let me quickly draw that for you so that you can see. So that triangle looks like this. So you have the height, 5 centimeters, and then you have the base, which is L, is 15 square root 3. So it's easy to find the area. So area number 4. Area of a triangle is half what the base times the height. So that would be half of 5 multiplied by 15 square root 3. And if you look at this carefully, it will simply be 75 square root 3 over 2 centimeters squared. Anyone who has a question?
Isn't the height 15?
Let me see the height, not 5, 15 on point. What a mistake. The lecturer would be happy already. What is 15 times 15? I think we should all know squares until we get to 20.
Say,
Yes.
isn't the right angle, wait, like this, the triangle, like the right angle is up there, not down, because down there was theta.
Yes. And what are you?
I
Okay,
thought the height would be L.
Okay, so let's write the triangle the way you want. So you know that we can move the theta around. So if we adopt this sketch which I have here, the theta will simply be there. You want us to rotate it. Are you still there?
Oh, okay, yes, I can see now. Thank you.
Yes. So remember, for a right angle triangle, where the angle is at, it does not matter because you just multiply the two sides and divide by 2. So what is 15 times 15?
It's 225.
Is what?
225.
Is 225. Yes. Please ask. You have a question? Okay. While we wait for the question, let's quickly compute the total area. And that total area, as you can see, it will be A1 plus A2. That's the area enclosed by the belt, plus A3, and then plus A4. Okay. So which means the area they are looking for there should be just the sum of these things. That would be 400 pi over 3, and then plus, other one is 25 pi over 6. The other one here is 75 square root 3. Then now what we have is 225 square root 3 over 2. This would be all in centimeters squared. I will wait for a question. Please go ahead and ask. There was a gentleman who wanted to ask a question. Are you answered? Okay, and then a question is, do we have any one of you as another problem from the study guide which they would like to get help on?
Yes.
Which problem is it? Yes.
How to find the limits of sec theta minus 1 over theta squared.
Okay, so let me just call it question 1 here. So what was the question? Find the limit.
Find the limit as theta tends to 0.
Okay, give me a second. So that would be the limit as theta approaches 0 of what?
Sec theta minus 1
Sec theta minus 1
over theta squared.
divided by theta squared.
Yes.
Okay. So what we can do here, we have two things which we can possibly do. Is which section, under which section is this part?
Limit.
Can you please repeat? I cannot hear you.
Under differentiation of sine and cosine.
Okay, under limit. So the question is, let me ask you so that I understand where you are at. Someone has their YouTube open at the same time. Please close your mic. So do you remember what the limit of sine theta divided by theta is as theta approaches 0? Did you find yourself doing anything like this?
Yes, sir.
What is this approaching?
1.
1. You did it in class.
Yes.
Okay. What is the limit of theta as it approaches 0 of cos theta?
Sine theta.
1.
Okay. And then this would approach 1. And then obviously the limit of theta as it approaches 0 of sine theta would approach 0. So now the question is, how can we work around this and find the answer they want? We need to think harder. Anyone who has a suggestion? And please remember that our sec theta is equal to what?
1 over cos.
Is 1 over cos theta. So what can we do here?
We can change sec theta to 1 over cos, then.
Okay. And when you were doing limits, just a quick question, because this problem is easy, but it depends on how much work you did. Did you hear of anything they call L'Hopital's rule by mistake?
No.
Okay, no problem. If that's the case, then let's try and work with cos and sine and see what we get. So this we can write as that. So the sec we can write as 1 over cos and then minus 1 divided by theta squared. And then let's quickly try to make a common denominator there, so that what we will have is the limit as theta approaches 0 of, we'll have 1 minus cos theta divided by theta squared, and then I'll have my 1 over cos theta here. So if we try to substitute 0 in our equation here, you look carefully, if we try to substitute our 0, what we will have is that you'll have 1 over cos of 0, and then minus multiplied by 1 minus cos of 0 divided by 0, which are, yes.
Where does the 1 over cos at the beginning come from?
Oh, you mean the 1 over cos t?
Yeah.
Okay, let me quickly, thanks for the question. So if you make a common denominator here, you see that you will divide by cos, isn't it?
Yeah.
We'll have that cos theta, and then that theta squared was still there. Do you understand now?
Yeah, I understand now.
So we can just put the 1 over cos theta outside there, because it's just dividing that numerator there, which is just 1 minus cos theta divided by theta squared. Do you follow?
Yeah, it makes sense now.
Okay, the problem which we are facing here, good people, is that when we take the 0 and put it here, we get a 1, and put it there, we get a 1, then we get a 1 minus 1. We put it there, we get a 0. So we find ourselves with 0 over 0. And what is 0 divided by 0?
It's undefined.
On point. So 0 divided by 0 is undefined. So when they said back in primary that a number divided by itself is 1, we're not right. So let's quickly have a look at what we can do when we encounter such a situation, because we are avoiding 0 over 0 as much as we can. So what should we do here?
What if we rationalize the equation?
By introducing which trig ratio? 1 plus cos, would you say?
Yeah, I don't know, sir.
Anyone else with a suggestion? And the person who posed the question, which tutorial question did you get it from?
Tutorial 251 D3
251.
in calculus.
You said 251.
D3, yeah.
1D3. There it is. Let me quickly look at that. Okay, let's quickly try and rationalize this.
Say,
Yes.
there's this identity which says 1 minus cos h over h. So can't you use it in this option?
Can you please repeat?
There's this identity which
It says 1 minus
cos h all over h is equals to 0.
It is equal to what?
0.
0.
Yeah,
And what else?
it's just like this.
Okay, let me see if we missed that. Because if that's the case, life becomes easy.
Yeah.
Give me a second. I'll put it under the notes. Wait. Okay, we have that one and that, and that. Okay, so let's have a look at what will happen when we utilize that. So the limit, as our theta approaches 0, 1 over cos theta, this is not a problem in any way. And then what we can have is 1 over theta multiplied by 1 minus cos theta over theta. So everything else does not matter if we will find ourselves having a 0. So this portion here will give you a 0. So meaning anything multiplied by 0 will always give us 0. So let's add it here to where those things I wrote. For that, did this thing delete my other notes? Oh, here they are. I should have made a copy. Okay, with these, let's quickly try another question from those. You can pick any. Let's see if we'll be able to do them. Someone, you can pick any question. And then also on the notes, what I want to add is that if we're taking the limit of sine of theta as it approaches 0, as long as it is sine of maybe k theta, some value divided by k theta, the answer will always be 1. Anyone, you can pick up any question here, and we will see what it will amount to. And equally so, as part of your notes, you should be aware that as theta approaches 0, if we have k theta divided by sine k theta, the answer will always approach 1. So anyone, we can pick up any question. This here is very important. So let's take the question which is on theta cot t, and then I can move on to the next question. And I'll call it question 2. So if they say find the limit as theta approaches 0 of theta cot t, not cos t. So the first thing I need to remember is cot theta is 1 over tan theta, which is just cos theta over sine theta. So it means what they are asking me to do here is simply to find the limit as theta approaches 0 of theta cos theta divided by sine theta. And because I remember my things, I will write this as theta over sine theta, and then put in the cos on the other side. And then I go and think of my notes, which I wrote here, which I should know on top of my head. Let's copy them and paste them this side. And then we just quickly have a look. So if you look at what is going on, what we have here is simply that when you have the limit as theta approaches 0 of something theta divided by something k theta or something theta, you will have 1. But at the same time, you can see that we just have cos of theta, and as cos of theta approaches 0, the answer becomes 1. So we are happy here because it means our answer is simply 1 multiplied by 1, which is 1. So our limit as theta approaches 0 of theta cos but theta, this will just approach 1. So these identities on the right-hand side are important. Anyone else who has a question? Anyone who has a question they struggled with, please share it. If you have any question which gave you problems, you are welcome to share.
I had a problem.
Yes. Is it a calculus or an algebra problem? Anyone else with a problem? Please go
Yes,
ahead.
can you go to page 31 of algebra, sir?
3-1 of algebra. Give me a second. Where is algebra 3-1? Okay, what about 3-1?
Question E18.
3-1 question E18. Okay, rather give me the number because it looks like what I have here, E18. Okay, I see. What about E18?
Oh, so how do you do that question, sir?
What I can tell you is that, for example, question D, let me see, question D16, T17, and E18 is something which you will never come across. So what I can do for you is rather I can work it out and then share it in one of those groups. So you'll hardly do questions which we would regard as proof intensive rather. So E18, you'll never come across something like that. But I'm happy to do it for you separately. Anyone who has any other question which is troublesome, for example, D15 is something which they can take out. It is a question which is not too.
Yes, please do that one, sir.
So D15 doesn't need a lot of conceptual thinking. It is something which is not far-fetched. So if we look at D15, this would be algebra page 1, page 3-1, and we're looking at D15. I think I saw it in one of those groups. So in D15, they are saying if P, Q, and R are natural numbers, so P, Q, and R are natural numbers, then what? Such that P squared plus 1 should give you QR. And then they're saying we should prove that. What are we expected to prove? That the arctan of 1 over P is equal to the arctan of 1 over P plus Q, and then plus the arctan of 1 over P plus R, not Q. Okay, so essentially we need to prove that in simple terms, the right-hand side is equal to the left-hand side. That's what we are expected to show here. And what I want to remind you of is, if you look at this problem, it is not so easy to quickly work out. It doesn't make so much intuitive sense. But I want to bring you to your, what I want to bring to our attention is what you did earlier, which is why I will say remember. If you can remember, what is tan of A plus B? Was somewhere in the study guide, someone in the meeting, please come to the rescue.
Tan A plus tan B divided by 1 minus tan A tan B.
Tan B. Okay. This was covered some other time earlier, and if you go up your study guide, this is on page 91 or 19, sorry. So what we can then do is that we can take the tan of both sides when we look at the expression we have above. So take tan of both sides, because the right-hand side should be equal to the left-hand side. So what I do on the right, I should do on the left. So if I say tan of what is there, which is a tan of 1 over P, what you do on the left, as long as you do on the right, you are right. So I'll have tan of my tan of 1 over P plus Q, and then plus a tan of 1 over P plus R. Close bracket, close the bigger one. So if you look carefully, all what I have now here is simply tan of, I'll take that and make it to be A, so that I simplify it, and I take the other part, this one here, and we make it to be B. Okay, but if you can tell me, you remember, what is tan, or what is tan of something? We are dealing with the left-hand side now. You remember, what is this going to be equal to? Tan of the tan of something.
It's 1 over P. It's that thing, sir.
So in what I wrote in red, that would be equal to X, isn't it? Okay, so that means my left-hand side will simply be 1 over P. Then my right-hand side, I will use exactly that formula. So I can clearly see that what I will end up having using that formula will be the tan of A plus B, where my A is simply the arctan of 1 over P plus Q, plus tan of the arctan of 1 over P plus R, close the bracket, and then all divided by 1 minus the product of this. So I'll have tan, I'll write my arctan in that notation, P plus Q, and then tan into arctan of, let's create some space, 1 over P plus R squared, close that bracket. So if you remember, the arctan or the tan of the arctan of something simply becomes whatever the thing is. So that means 1 over P, which is what we hope this will amount to, is that we will have 1 over P plus Q. That would be this part. and then plus, if you look carefully, we will have the second part, which is that part, the green one. So the arctan, or the tan of the arctan of something, becomes whatever the thing is. So it would be 1 p plus r. And then divided by, we go to our denominator, that will be 1 minus 1 over p plus q multiplied by 1 over p plus r. So we can now multiply these things with the hope that we will get something. So let's multiply the numerator. We'll have 1 over p equals, if I multiply the denominator of the numerator, I'll have p plus q multiplied by p plus r. And then this is all divided by, you'll have p plus r plus p plus q. This will be divided by, on the denominator, the simple product, 1 over p plus q multiplied by p plus r. Okay, so let's quickly do some multiplication and see if this will check out. So if we look at the numerator, you will see that what we will have there, the top, you have what, 2p's. So we'll have 2p plus that r plus that q. The denominator there, when we do our foiling, you will see that it will be p squared. And then plus, let's quickly see, so p times p, pr, and then qp. So that will be pr and then multiplied by qp. And then we're done. P times that becomes p squared. Times that, it becomes pr. And then q times that becomes qp, which will make them to be 2. So let me just put in a 2 here. Yes.
So don't you think it's wiser to maintain like the brackets to until the final answer? Because when I'm doing it here, the p squared plus pr plus 2qp, they cancel with the other one. And then you can open at the end.
Okay, so what you're saying is that instead of multiplying, we can eliminate these denominators by multiplying with p plus q, which is literally doing nothing, unless you want to make a common denominator, but it will have the same effect. Then plus r, but what you do on the denominator, you do on the numerator. P plus r. This is what you are saying.
Somewhat, sir. Because what I did was I expanded the denominator, the 1 minus 1 over p plus q, p plus r. And then in the end, or towards the end, the p plus q, p plus r of the first numerator will cancel with the one in the denominator. And then you'll get a simplified version. Then you can expand.
Okay, it has the same effect. Essentially, when you are multiplying by the same thing to cancel out the denominator. So when we look at the numerator, you'll just have your p plus r plus, well, let's add them, it's 2p. So you have 2p plus r plus q, all divided by, that denominator will cancel. This one will cancel that. So if you look at the other one, that denominator will cancel that, but it will multiply there. So that what we have is simply p plus q multiplied by p plus r minus 1. This becomes the expression which we have, which is much more neater. You are on point. So we can try now and simplify this and see what we obtain. So we have 2p plus r plus q divided by, that will be a p squared. And then p times that will be a pr. And then qp multiplied by, let's see, pr and then qp. We'll have qp And then we'll have a QR. Okay, any questions? -1. Do we have anyone who has a question? EQR. So now let's go and look at what they said. So we are expecting this somehow to end up simplifying to 1 over P. We are hoping. Let's go and look at what they said to us. So they said that P squared plus 1 should be QR. So they said to us at the very beginning that P squared plus 1 is QR. So use this fact that wherever you see P squared plus 1, you can replace it with QR. Quickly. P squared plus 1 is QR. So what should we do from here? Thoughts and thoughts. So if this is true, how can we use it? We are given that P squared plus 1 is QR. So how can we use this? Obviously, we can see that wherever there's P squared, what you can alternatively do, you can replace with QR -1. That's another way of looking at this. What then should we do?
Sub QR -1 into the equation.
Okay, let's go and try that and see if it works out. So we have 2P plus our R plus our Q. So wherever we see the P squared, let's go and replace QR with QR -1, and then we will have our PR there, then our QP, and then plus our QR, and then -1. So how is this going to help us? So let's try and combine common terms. So if you look carefully, that and that, they look alike, so they make the 2 QR. And do we have anything else adding? We have a PR in that. Nope, they're not adding. So we have that plus PR plus QR -2. How is this even useful? Now the question changes. Should we not maybe replace QR -1 with P squared? Do you see that the equation is in 2 forms? So you have 2 options. Either you replace P squared with that, or you take that and you replace it with P squared. So let's go and try the second option. The same thing, but it is presented slightly different. So let's go and try the second case where we replace P squared, or we replace QR -1 with P squared. So how that is going to be is we'll have our 2P plus R plus Q divided by, we have our P squared plus PR plus QR, and then that will be a P squared. And then we quickly combine these. That will be a 2P plus R plus Q. Already you can see the answer is going to work out. We'll have P2, 2P squared plus PR plus Q, C plus QP, not QR, QP. So if you look at what we have here, we can factor out P, which is common on the denominator. So we can have 2P plus R plus Q divided by, if you look, we have P, which is common. When you factor out P inside, you are left with 2P plus R plus Q. And there you go, these will cancel. And on the right-hand side, you will now have 1 over P, but you remember that on the left-hand side, you had 1 over P originally. So this works out. Anyone who has a question, please ask. The person who said I should do this question, do you follow?
Yes, yes, sir.
Yes, so what we should take away from this here is that when you go about a problem, there's a certain way of simplifying which will need you to do a lot of work to get to the solution. Immediately when you see that I did simplify right, but I can't see how I'm going to get to the solution quickly. If there's another alternative, please switch to that very quick. That's what we did here. Anyone else who has a question? Yes.
I want to know how you approach the question. Like, how did you use the TAN theorem?
How did I use what?
The TAN identity to apply to solve this question.
Okay, no problem. So you do know this identity, which is in blue.
Yes.
Great. Then we said take tan on both sides. You know that what you do on the right, as long as you do it on the left, nothing is wrong.
Yes.
So if I put tan on the left and put tan on the right, I've done nothing wrong. And the reason why I put tan, you understand, is because there's arctans here, and I know that the tan of something, the answer becomes whatever the something is. Okay.
Yes.
So when I look at my right-hand side, I will look at A as if it is that arctan of 1 over P plus Q, and my B as that arctan of 1 over P plus R. Do you understand that?
Yes.
So essentially, we have tan of A plus B. Then when I go up there, I apply the identity of tan of A plus B. Tan of A plus B gives you tan of A plus tan of B divided by 1 minus tan of A multiplied by tan of B. Do you understand that?
Oh, yeah, yeah.
Okay. And then you remember that tan of something becomes whatever the thing is. So tan of 1 over P plus Q will become 1 over P plus Q. Same goes here, here, and here. And then I just made a common denominator by adding those and multiplying them in the denominator. On the numerator, I'm going to multiply them also. Do you understand?
Yes, yes, thank you.
Okay. Then from here, it is just normalizing this to get to the final answer in manipulation. Anyone in the session who has a question, please go ahead and ask. Which question did you get stuck on? And let's see if we can try and figure it out.
Say,
You can
go
ask.
ahead. Yes.
Okay, sir, can you hear me?
Loud and clear.
Okay, I need help with decomposing fractions into partial fractions. So that would be on page 13 of our algebra guide.
You go to your page 1-3. Yes, what exactly on page 13?
Example 1.7.1.
Okay,
D6.
let's start.
Okay.
So you're saying D6. Okay, let's
No,
take
we can start with 1.7.1 and then go down.
The one where they say decompose.
Yes, decompose into partial fractions.
Okay. So let's look at example 1.7.1. So they are saying there we should decompose. And what we're looking at is partial fractions. And if you look at the question, we're given x cubed, all divided by x squared minus x. Let's see, it's minus 2x. Minus 2x minus 3. And then the first thing which you can do is, if you can, try to factorize your denominator. So if you look carefully, we'll have x cubed divided by x minus 2 numbers, which when you multiply, you get -3. When you add them, you get -2. That would be -3 and a +1. So that's the first step you should take. Try to factorize that denominator. By all means, try to factorize. We'll see cases where you can't do that. So after factorizing, you now are in a position to start working. So because we have linear factors here, so this is linear and that is linear, we were able to factorize that.
How is
So
it
your
linear?
a straight line equation, is it a linear equation? So you remember that y is mx plus c, that's a linear equation, isn't it? Do you remember that?
Yes.
So the factor is a linear factor. It is not a quadratic factor or anything after factorizing. Because there's cases where you genuinely cannot factorize. Then you would leave it as a quadratic vector, but this is a linear vector. Do you understand why?
Yes, we understand.
Okay, so what we should do is we'll have our x minus 3 and then times our x plus 1. So this here will be, because this is a linear vector, we'll have a. So how I want you to think about this is, give me a second, I'll introduce you to something. So x plus 1. So when you do your partial fractions, what will happen is if you have a linear factor, on top of the linear factor, you'll have a constant. If you have a quadratic factor, on top of that, you will have a linear equation. So essentially, the degree, let me quickly show you what is a degree. So if we have, let's say, 3x squared plus 2, the degree here is 2. And then the degree of, if I have 40 cubed plus 7, the degree here is 3. If I have t plus 1, or rather we can make it to be even x, let's make x's here to get the point across. The degree is 1. So from looking at this, what can you say is the degree here? What is your conclusion? What is a degree of a polynomial? Because what is inside here, we call it a polynomial. Your quadratic functions, which we were doing back in high school, we just call them polynomial. The quadratic function, we call it a polynomial. Your cubic function, it's a polynomial. Straight line equation is a polynomial. So by looking at this, what would you say is the degree? Where am I getting these numbers?
I
So
think
look
it's the highest power.
on point.
The highest,
So
yes.
the degree is the highest power. The degree that the highest power would be 1 in that. So if I have that as, and then I say the degree of a constant, say 7, what would it be? Give it some careful thought.
0.
0 on point. So the degree of a constant is 0. So what you should do when you do your partial fractions is that the degree of your numerator of the num numerator will be 1 less than the degree of the denominator. This is important when you do your partial fraction. You should know the degree of the denominator should be 1 more than the degree of the numerator. So for example, if I have x squared plus 2x plus 1, my numerator when I do partial fractions, I would make it to be ax plus b. And guess what? This here is degree 1, and my denominator is degree 2. And this is always what I want. The denominator should be 1 more than the numerator as far as the degree is concerned. And then let me come at you and say, if I have x cubed plus 1, and I'm doing partial fractions, what should be on my numerator?
Ax squared plus bx plus c.
Plus c, on point, because the degree of the denominator should be 1 more than the degree of the numerator. Or the other way around, you can say the degree of the denominator. That makes sense now why I took x plus 3 and then on top I put a constant. It's because the denominator is degree 1 and the numerator, which is a constant, has degree 0. Hope that makes sense. Let's come and carry on with our problem on the next page.
Sir, please repeat what you just said.
So I said the reason why I have a constant there on top of x minus 3 is because x minus 3 has degree what?
X minus 3 has degree 1.
Degree 1.
And then we said the numerator should always have a degree, which is what? 1 less the denominator. So a, which is a constant, has degree 0. So that's why it is there. Okay, does it make sense?
Yes.
Yes.
We'll see examples as they come. And then after you do this, what you should do is you should multiply out. You should multiply the right-hand side and the left-hand side by the denominator. That denominator, so that things cancel. So you'll multiply by x minus 3 and then x plus 1. So when we do that multiplication, you will see that we'll have x cubed over, I have x minus 3, x plus 1, x minus 3, x plus 1. You will see that what we will have is a over x minus 3. I will multiply by x minus 3, x plus 1. And then when we go to the b part, which is over x plus 1, we will multiply with the same thing, x minus 3, x plus 1. So essentially, you will see that there's things which are canceling here. All of that will cancel that. This will cancel that. This will cancel that. So that what we have when we look at the right-hand side and the left-hand side, try and make some space here. Plus, pull that up, and all of this should go up. So if you now look at the left-hand side, it is left with x cubed equals a multiplied by x plus 1 plus b multiplied by x minus 3. And remember, when we're doing partial fractions, what we are trying to solve for is this a and b. So we need to solve for a and b. So how can I solve? Let's say I want to solve for a. Let's say I'm interested in a for now. If you look at a, how can I solve for a? If I can make this bracket here to be 0, I would be happy. The bracket to be 0. Because I don't need to stress about B, there will only be A left. And how can I make that bracket to be 0? Well, if I set X to be 3, that bracket will go away, so I don't need to stress about the B. So if we make X to be 3, on the left-hand side, we'll have 3 cubed equals A multiplied by, wherever we see X, we'll have 3 plus 1. Then B into here, we'll have 3 minus 3, which will make sure that I do not really stress even about the B because it will be multiplied by a 0. So let's go to the next page and see how this unpacks. Please stop me if it does not make sense. So now when you look carefully, we'll have 3 squared or 3 cubed, sorry, which will be 27. And then we will have 4 times A. So you can clearly see that our A will simply be 27 over 4. Now I'm done with A. And then I'll come back and ask myself, what about B now? And we'll take that expression and write it down and see how we can find B. So when I'm looking for B, I will ask myself, how can I make these equations such that it's only B which is left? Well, I do not want to stress about that A. So I can remove that A bracket if I choose my X to be -1. So I won't need to stress about the A. So let's put in -1 cubed, and then we'll have A into -1 plus 1. That's why I chose X as -1 because things will cancel out. And then I'll have B into -1 minus 3. So you will see that I become happy because that bracket becomes 0 and I'm left with my B, which is what I need to stress about. So -1 cubed will be -1. And then you will see that we have B multiplied by -1, -3, which becomes -4B. Then when we divide, we will see that B will be 1 over 4. So our partial fractions, X over X squared minus 2X minus 3, that will be our A we found as 27 over 4. So that will be 27 over 4 multiplied by 1 over, let's see what the A was multiplying X minus 3 plus our B is 1 over 4 multiplying 1 over our X plus 1. This would be the solution they're expecting you to produce. Do you understand? People in the meeting, do we follow?
Why do we
Yes, I
multiply
understand.
instead of dividing?
Can you please repeat?
Why do we multiply instead of dividing?
Remember that A was sitting here.
Yes.
So why should I divide by A? Because A is now 27 over 4. So A should be multiplying that 1 over X minus 3.
Okay.
Or if you want, because A become that, do you like writing it this way, 24 over 7 like that?
I thought it was supposed to be written this way.
You can, it's the same thing. Do you see that?
Yes.
Yes, because if I have 3 over 2 divided by 4, this is the same as taking that 3 over 2, multiplying it by 1 over 4.
Okay.
So let's remove that and put in our 1. So that's how you would work out that problem, putting the cube there. Anyone in the session can pick another problem on partial fractions and we'll see how are we going to go and deal with that problem.
Sir, can we do D6C?
And F on D6, F.
Okay, please repeat.
D6, number C. Can you hear me, sir?
Loud and clear.
Okay.
D6 number
C.
C. Yes. Let's go ahead and give it a shot.
Okay.
So, yeah, it's x to the 5. I pray they do not give you anything like this, but believe me, it is easy. Let's see what we need to do. Divided by x to the 4 minus x squared minus 2x plus 2. So we have a problem here. Anyone in the meeting, tell me what the problem is. We said when we want to do partial fractions, we need the degree of the denominator to be what compared to the numerator?
1 less the degree of the denominator.
So can you please try again?
I think the problem that you might be talking about is that the degree of the numerator is the one above. Yeah, the degree of the numerator is now more than the degree of the denominator and not less than.
Exactly. So when we look at this problem, we are like, what? So the degree of the numerator, which we do not want, is greater than the degree of the denominator. And then when we have such a case, the first thing we should do is do long division. We should do long division here. That's the thing we should do. So let's go ahead and do long division. So long division, we have x4 minus x squared minus 2x plus 2. And then we have that x to the 5 plus 3x cubed plus 2x plus 1. Let's see if I captured the question right, because one mistake here screws us up. It looks about right. Let's look at the denominator. Plus 2. Okay, so let's do long division. If you remember, good people, with long division, what you do, you take this here, you will go and divide by x to the 4. So what is x to the 5 divided by x to the 4? Easy stuff. What is the answer?
X.
X minus. And then what we do is the answer which we get, we will take it. That answer should multiply everything which is down here. And when we multiply that, we'll get x to the 5 minus x to the 3 minus 2x squared plus 2x. Okay, and then we subtract these two here. So you will see that our x to the 5 and x to the 5 will cancel. And then what we will be left with is that we will have that 3x cubed plus another x cubed, because the minus will make a plus, such that we have 4x cubed. And then we will have a 2x, look carefully, you'll have that 2x minusing the other 2x, which will give us 0. So this 2x here, it will minus that 2x, which will give us a 0. So what we now have is the other one, which will be positive 2x squared, and then plus 1. This is what we have. So what is going on here? What comes here at the top is the actual division. Yes.
X times negative 2x, it's negative 2x, not positive 2x. So 2x minus into negative 2x, it's not 0.
Okay, let me see what you are saying. So let's zoom in a bit. So you can see the negative which is out here, isn't it?
No, x times negative 2x from the divisor, it's negative 2x squared.
X times negative 2x, it is negative 2x.
Okay, I can see now. I'm wrong. Okay.
Okay. So what is left here is the remainder. And if you guys remember, is that how do you write the final answer if you were dividing? So this here at the top, when we now write it, it will be equal to the number or the value which we get there at the top sits down, plus what is left here, it becomes the remainder, meaning we will have that 4x cubed plus 2x squared plus 1. It will be divided by the denominator, which is all of those numbers there, x to the 4 minus x squared minus 2x plus 2. Now the question is, does this look more right now? Does it look a bit better?
Yes, because the numerators, the degree of the numerator is now less than the degree of the denominator.
On point. We are now happy because we have achieved that. So since they're saying we should do partial fractions, we'll only focus on the part which needs partial fractions going forward. Let's take that to the next page and invest our time and break it down. Need to add a couple of pages here. Let's see, paste that there. And then if you remember, the first thing I said we should try and do is to try and factorize that denominator. So let's see if we can try and factorize it. I'll just focus on it, denominator. And that denominator of ours there is x to the 4 minus x squared minus 2x plus 2. This looks like something which we could do back in grade 8. We have a common factor here, which is x squared. Then I'm left with x squared minus 1, isn't it? Then when I look at these two here, they have a common factor, which is minus 2. Pull out that minus 2 there, you will see that you will get x minus 1. Okay. So that's what we have. Then let's see if we can expand this further. So I have x squared. That x squared minus 1, I know I can write it as x plus 1 multiplied by x minus 1. I'm minusing that 2 of mine, x minus 1. So if you look carefully, we have a common factor of x minus 1 here. So I can say x minus 1, open bracket. What will be left inside will be x squared times x plus 1 minus 2. So that's what we have. And I cannot see any way which we can try and factorize that. So maybe we just need to FOIL what is inside and make it to be 1, such that what we have is x minus 1 into, we have x cubed plus x squared minus 2. So that's our denominator. So let's go ahead and write it. We'll have 4x cubed plus 2x squared plus 1, all divided by, we have x minus 1 into x cubed plus x squared minus 2. And then what we need to realize is that, okay, this bracket, we can't break it into linear factors. We are okay with that. We will need to accept that reality. So what we will do is, since we have now two brackets, I will have A divided by x minus 1, that's one of the denominators, plus I will have bx plus c divided by k, that is cubed. So it will need to be a bit packed. So we'll have bx squared plus cx plus d over x, sorry, over x cubed plus x squared minus 2. Why did we write this way? It's a question for all of you. Why did I, when I was breaking my partial fractions, write the right-hand side as I did?
Because we divided by a cubic function, so the numerator has to be a quadratic.
On point, it has to be 1 degree less. And since we have degree 3 on the denominator, the numerator must have degree 2. Degree 2 means quadratic. On point. And then what we can do is we can multiply by the denominator all over. Multiply by the denominator all over. So what that looks like is the right-hand side or the left-hand side will be just that plus 1. The right-hand side will simply be a multiplied by the other denominator, which is x cubed plus x squared minus 2. And then we will have that be x squared plus c x plus d. It will be multiplied by the other denominator, which is x minus 1. Okay, so the easiest thing to figure out here or to find is a. And the question is, when I look here, how can I find a? I need you to think carefully. I'm only interested in a here.
If we say x is equal to 1.
If we say x is equal to 1.
I think x is equal to 0 would be right.
Okay, so when we put in x is equal to 1 here, this will not work at all. Okay, I see why. Okay, so because x is equal to 1 is not so easy, we'll need to go the hard way, we'll need to do a number of trials. Because x is 1 will just give us a problem all over. Let me think. X is 1.
X is equal to 0.
Okay, let's try x is 0. It will leave us with 2 variables. So we have 2 things which we can do here. Let's try x is 0, it's okay. When we do x is 0, the right-hand side, the left-hand side will be 1. Then the right-hand side will have that a there. These will be zeros, will be multiplying by -2. And then plus, if you look at all of these, because we're putting x is 0, there will be 0 besides the d. And then we'll be multiplying by -1. So essentially what we end up getting is that -2a minus d should give us 1. What else should we do now?
I think x should be equal to 1 because if you look at that bracket bx squared plus cx plus d, it is attached to x minus 1. And if you let x be equal to 1, we're going to get 0 there. And hence we will be left with only one variable.
But then do you see that when you put in 1 here, you have 1 cubed plus 1 squared minus 2, which will be 0 also. So let's quickly let's proofread our solution. Let me come here. Yes.
What if we use
wait.
What if we use the cover up method?
The cover, you mean the cover up rule? So that would work. It would work perfect here only for A. Are you aware of that?
Yes.
Because A is the only linear function here. But then here's the problem. The cover up method, I'll quickly come back to the person who wanted to ask. It would say cancel that, isn't it? And then figure out what would make the denominator of A to be 0, which would be 1. When you put in 1, do you see that you'll have a division of 0?
Yeah.
Yes. So do you see why it wouldn't work here?
Yes.
Okay. Anyone else who has a question, please ask.
Oh, sir.
Yes.
I wanted to give a suggestion. I'm not sure if this will work. So if we check our right hand side, with our denominator, we have x minus 1 and then x cubed plus x squared minus 2. So if we check that bracket which has got x cubed plus x squared minus 2, it's a cubic equation. We can try to factorize it.
You are related to n stay. So let's have a look at that denominator. So what we can do, we have two options. We can try and let's see. We can try and be smart and say, what if we had negative x squared, and what if we had 2x squared minus 2? But that would not work. No, I can't factorize this. The problem. Yes, please go ahead. But x is 1 solves this. So you were saying we should divide or find the long division using x minus 1.
Yes, or we can use synthetic division.
Okay, let's quickly figure that out. X cubed plus x squared minus 2. This will leave a remainder, which will be a painful problem. But let's go ahead. So you'll have x squared here, multiplied by that. You'll have x cubed minus x squared. And then when you take in... Yes.
Okay. The instructions say that we must not attempt to find the values of the unknowns.
Oh. Why? Write down the partial fractions below. Remember to first divide the numerator. Do not attempt to find the values. Evaluate the unknowns of the numerator. How? This is soft life. Because, okay, so, we are busy here thinking in 5G, and Wits is requiring us to think in 2G. So when we get here, we would be good as done, because we understand that ideally the numerator should have a degree less than the denominator. Your lecturer would be happy. Only for you to think in 7G as. So I'm happy. Let's get another problem. I'm now excited because this thing is so disappointingly easy. I'm surprised. So let's go for another problem. Anyone can choose. Because if we don't need to solve for the values, can you please repeat?
G6F.
G6F. Let's see. Yes. You have a question? Okay, the person is silent. Do you have a question?
Okay,
so if you look at yes.
So the answer you highlighted, the thing you highlighted in pink, is it the answer?
Looking at the fact that they are saying we shouldn't solve for the unknown, this would be the answer.
Okay. Thank you.
And then one thing you should remember is different presentation of answers. In the book, they might choose to have the b squared and separate the numerator such that they just have a common denominator. So you should try and manipulate a way such that it looks like theirs, but you wouldn't be penalized if you wrote this. The lecturer knows maths very well. So let's look at f. F has x to the 4 plus 2x squared plus 9. This should be easy. What should be on the denominator when we do partial fractions? Can we split that denominator? We certainly cannot. I cannot see how you can factorize that. Two numbers which multiply to 9 and add up to 2. There's no way you can find them, so we leave it as it is. What should be the numerator? Should be a song now. What's supposed to be the degree of the numerator?
3.
Yes, but then this is very odd. Minus 4ac. So this will just be what it is. Do you see that? So if we try to, yes.
So the memo had broken it down to factors by saying x squared minus 2x plus 3 and x squared plus 2x plus 3. Is that correct? Because it doesn't seem correct.
Okay, let's quickly think around that. So if we can, let's do something like this. Let's say k is equal to x squared. We'll just try and see if we can factorize that. So that would mean x to the 4 is k squared. So I'm just looking at the denominator. So when I'm looking at the denominator, it will be, if I do this k substitution, it will be k squared plus 2k plus 9. So let's try and see if we can factorize this. So we will use the quadratic formula to try and find the factors. So that would be minus 2 plus or minus the square root of, we will have 2 all squared minus 4 times AC, which would be 1 times my 9. So this looks like it will not work when I'm attempting to use this equation here. So we need to try and factorize this in another way without using this way, because it will give us a problem on that 9 there, as you can see. Okay, so if you look at what they have, they were able to factorize that expression, that x to the 4 plus 2x squared plus 9. They were able to factorize it into x squared minus 2x plus 3, and then x squared plus 2x plus 3. This is what they were able to factorize that to. So let's quickly see, if you FOIL it, you will get the same thing. So the x cubes will cancel, and then I will have a minus 6. Let me see, is this, they are that. Let's quickly FOIL this and see what they are saying. So if we quickly FOIL, you'll have x to the 4, and then that will give you 2x cubed. That and that will give us plus 2x squared. Just want to test what they are saying here because it's very odd. Then that times that will be minus 2x cubed, and that times that will be minus, let's see, 4x squared. And then that times the 3, it will be minus 6x. And then let's multiply the 3, which will be 3x cubed. And then 3x squared, sorry. And then the 3 times that, it will be 6x. And then plus 9. So let's simply see how these terms are going to cancel there. So we have that cubic term, it is going to cancel with what? So this cube and that cube will cancel, leaving us with this here. No, that is squared. So the cube will cancel, that will cancel that. And then we have a 2, and then we have a minus 4, which makes it to be minus 2. And then we will have a 3. So what would be the coefficient of t of x squared here? So 2 minus 4 plus 3. That would be 1. Do you all see that?
Yes, I will see that.
So yes.
I think you made a mistake when you had to, when you said x squared, you should have times x squared times 3. You forgot to say x squared times 3 when you're doing 4.
Let's double check that. So the x squared times that. Yeah. Let me see 2 and then 3 there. And then let's quickly double check the others. Minus 2 times that, it becomes minus 2x cubed. And then minus 2 times that, we should get negative 4x squared. Minus 2 times that is negative 6. So if now we have a 3, and then let's see now the x squared. Did we make a mistake elsewhere? Please have a look. The last one is the 3, 6, and 9. That's okay. Here we should have minus 2. Where is that minus 2x squared? For this, that would be cubed. Minus 2, it is that. Then that and that is minus 4x squared. That and that is minus 6. Are we now okay? Okay. So if you look carefully, we'll have 3 plus 3 minus 4, which will give us the 2. So they were able to factorize that. Very interesting. So it means our answer would be 1 over, yes.
Also, they left a note saying in F, we must add and subtract 4x squared in the denominator in order to factorize.
Let me see. They gave you a hint on the question. Let's see.
Yeah, it says in F, add and subtract 4x squared in the denominator in order to factorize.
Okay, let's go ahead and do that. I didn't see it. So if you look at our F, we have 1 over, we have that x to the 4 plus 2x squared. So the nice thing is that it looks like they will guide you. They said we should add 4x squared and subtract it, 4x squared. So let's go and have a look at how this can translate to what they have there. So if we subtract, or if we start by, let's see what we should start by doing. So we have a plus, that will make it to be a 6. And then that will make it to be a 4. So let's go ahead and try and figure out how from this we can get to where they want us to. So let's think carefully. The x to the 4 will remain where it is. Someone in the meeting, let's think. We have a 9. How are we going to work around this? Any suggestions? So we were given that tip. We need to figure out how do we use it to what we want.
So why didn't we add 2 and 6? I mean 2 and 4.
Get 6.
Yeah, then it will give us 6x squared. Then we can take it from there.
Plus 6x squared minus 4x squared plus 9. Okay, so we need to think after this, what do we do from here?
Plus 6 squared
X
plus
squared
9.
plus 3.
I cannot hear you.
X squared plus 6. X squared plus 3x squared. All squared.
I cannot hear you. Please come again.
X squared plus 3x all squared.
How did you figure that out?
We have x to the power of 4 plus 6x squared plus 9. I excluded minus 4x squared.
Why are you excluding it? We'll
Because I
deal with that.
wanted to factorize this other part.
Okay. So the other part, we can clearly see that it will be. So for example, when you look at this, and that, we can all agree that it will end up giving us x squared plus
3 all squared.
Let me think. That will be a 3. And then do you see that? And then it will be squared. In fact, no, it should be squared. Yes, it is that. And then that will be minus 4x squared over 1. And then this looks like 1.
Which school? We must go there. Yeah. Which library? We go to CLM. That place again.
Say, I'm thinking, can we do a grouping?
Yes. So you do agree that the pink part will give us. The guys who have their mic unmuted, please mute yourself. Your friend is a distractive friend. You are doing maths and they are saying, let's go and play. They are done studying, that's why. Anyway, let's come back to this. So do you all agree that the pink part will give us that x squared plus 3 all squared? And then if you look from here, this looks like a what? Look there. It looks like a what? A difference of 2 squares.
General equation.
Looks like a difference of 2 squares. Let me write it for you this way. So 4x squared, we know we can write it as 2x squared. So this looks like a difference of 2 squares. So what we can do is we can go and have our x squared plus 3 plus 2x. Then the other difference will be minus 2x. So that's why at the end, they ended up with that, which was 1 over x squared plus 2x plus 3, open bracket, x squared minus 2x plus 3.
It makes sense. Thank you.
Then, so that there, you remember, is just the difference of two squares. So when I started the question, I didn't read the hint. So please, unlike me, when you are given a tutorial question, if they give you a hint, please read. It's going to make your life to be easy, not make the mistakes I do. And then when we get here, life is easy. We can all agree that what we are going to have will be ax plus b divided by, we can no longer factorize that. I will have x squared plus 2x plus 3, plus I will have cx plus d, all divided by x squared minus 2x plus 3. Why do I have what I have here as the solution? Someone in the meeting can shine.
The denominator is quadratic, so the numerator should be linear.
On point. Any other question which you came across and you found as a problem, please shout.
Calculus.
What about calculus?
Question tutorial 2.4.1, question T2B.
Let me go to, you said tutorial
2.4.1.
2.4.1. And which question did you find as a problem?
T2B.
Calculus, looking at 2.4.1, and you are saying it is D2 what?
B.
B. Okay. And then they are saying use the rules of differentiation to find the derivative of. So essentially here we want to find the derivative of what is down there, and this is with respect to y. So let's see. With respect to y. So we with respect to y. This is easy. So they gave us that we have y log of 2 to base 10 and plus log 10, 3. So here's what we know. This here we might not know what it is, but the point is it's just a number. And this here, we do not know what it is, but well, it is just a number also, whatever it is. So now we are just differentiating y, or we are differentiating with respect to y. And we only see y multiplied by a number. So dy, because they said with respect to y, when we differentiate all what we see here, that part there, when we differentiate, it will be 0 because it is just a constant. You remember when you differentiate x plus 2, the 2 becomes a 0. And then here, when we differentiate, it's only the y which is going to be 1. And then this here will be left. So essentially our answer will simply be 1 times log of base 2. Well, it's log base 10. So it's log 2 base 10. And then plus 0. So essentially the answer which they are expecting you to have there is simply log of 2 base 10. That's the answer. Do you understand?
Yes.
Okay, any other question? question you came across and you got stuck. Anyone with a question? If no one does, then we can all go to sleep. Calculus and algebra. Which question did you come across and it gave? Okay. One is a question, we can call the session to an end. So the aim is to just answer your questions. I do not have any questions I prepared for you or questions I think we should do. I'm taking questions from you. Maybe if we do get some time tomorrow, maybe I can plan questions for you. But as far as where I am, I'm just taking questions and I'm answering those questions. There are none, then we can call it a day.
Sir.
Please go ahead.
Last one. In calculus 2.5.1.
2.5.1. Yes, what about 2.5.1?
A.
2.5.1a.
Yes.
Let me see, where is even that? Tutorial. Are you speaking about tutorial questions?
Yes.
There's a tutorial question on 2.5.1 under A.
D5A.
E5A. And they're saying write down the derivatives of with respect to x. Okay, let's quickly go to D5A. We are still on calculus. Let me just put it on the previous page. It's okay. So we are at D5A under 2.5.1. So if you look at A, they are saying find the derivative with respect to x. Essentially, what we are deriving is negative sign x plus square root 3 cos x. And let's go ahead and start here. What is the derivative of sine? Anyone?
Cos.
It is cos x. Okay, let's go ahead. Plus square root 3. Now we are here. What is the derivative of cos?
Minus sine x.
It is minus sine x. So when you try to simplify this, you will see that you have negative cos x minus square root 3 sine x. The person who posed the question, are you answered?
Yes, sir. Thank you.
Okay, my back. Please confirm if you can see my screen now.
Yes, we
back?
can see it.
Hey, on point. The person who posed the question, are you answered? These are your takeaways. This is the only good takeaway. It was a soft question. Any other question from anyone?
Sir, I have a question on algebra.
Yes, let me quickly switch to that. What about algebra?
Question 2.3.3 on page 22.
2.3.3.3. And you said it's page what?
22.
2. And yes, what about that?
I couldn't understand how they reduced the thing inside the bracket.
So is it the one where we have arctan of a half at the top?
No, question. No, the last, oh, so the last question then. So the last one.
Which one?
Arc sine into sine 2/3 pi.
Let's go in there and look at arc. We're looking at the arc sine of the sine of 2 pi over 3. And what are you trying to figure out? You're trying to figure out what is this equal to. Is it? Let me just equate it to x. Is this what you are trying to figure out? Are you still there?
Yes, I am.
Okay. So the first thing which we need to see is that they gave you some notes which you should be aware of, because you remember that a function should pass the vertical line test. So if you look at your notes which are under in general, write that for you. So what we are saying there is that the arc sine of something, that will be equal to whatever the only thing, that is if that thing there is an element which is between negative pi over 2 and pi over 2. So that is what is going on here. So what I want to bring to attention is that this here was going to be that only if that is between the question, or maybe the question I should be asking you is that, is 2 pi over 3? Let's focus on the inner part so that we get this right. So focus on the inner part where we have sine of 2 pi over 3. And the question is that, is that 2 pi over 3, is it less than pi over 2, but greater than negative pi over 2? Is this true?
No.
No. So how
Yes.
can we make this to be, someone is saying yes, someone is saying no. What is going on?
No.
Okay, so what I want to remind you is, for the ones who are saying yes, remember that 1 over 3 is something like 0.33. So when we have 2 over 3 multiplying something, it means we have 0.66. And 0.66 is greater than half. Because what you should see, look at this way. We have a half multiplying pi, and then we have 2 over 3 multiplying pi, and then we have a half multiplying pi. So we only need to focus on these numbers because the pi's are there. So as you can see, that number there is 0.66. That one there is 0.5, and that one there is negative 0.5. So this is not true. So we need to try and make that angle to come back to this range here. And if you all remember, sine and cos are sinusoidal with what period? The period of sine. What is it? Sine is periodic, if you remember, in 2 pi k intervals. That's what we were doing back in high school when we do K360. So meaning, if you look at the sine there, that sine of 2 pi over 3, if I say plus 2 pi k, I haven't changed anything. So if I choose k is -1, look at what happens. I'll focus on the angle. I'll have 2 pi over 3 minus 2 pi. And then let me try and make a common denominator here. I'll have 2 pi over 3 minus 6 pi over 3. So when you have a look at that, we'll end up having minus 4 pi over 3. And this is not helping in any way still. So how can we work that out? So this did not work. What can we do? 2 pi over 3. How can we reduce this? Anyone? How can we make that angle to be between negative pi and negative pi over 2 and positive pi over 2? That's the problem we are facing now. Can we even make it to be that? It appears we cannot. Anyone who has a different suggestion? So what you should remember is, let's come here and see what this is. Let's look at sine so that life becomes simple. So we have sine of 2 pi over 3. What is this angle in degrees? Anyone knows?
I think.
What is 2 pi over 3 in degrees?
60. It's 60 degrees.
2 pi over 3.
It's 120.
2 pi over 3 is 60. How is it that it's 60? It can't be 60. It is 120. It cannot be. So
It's 120 degrees.
So we have sine of 120. And if you all remember, what is sine of 120 equal to? So if you remember from back in the days, sine of 120 would be 80 minus what?
60.
60.
Minus 60. So this means sine of 108, sine of 120 is the same as sine of 60. So this means this thing is equal to sine of what in radians? What is 60 in radians?
Pi over 3.
Pi over 3. So this means what we have there, that arc sine of that sine, it is the same as pi over 3. And then now when we look at what they gave us here, you will see that they said as long as that angle is between negative 90 and positive 90, we are sorted. So the answer simply becomes pi over 3. Do you understand? I think my advice here would be, as much as you can, try to write these answers in degrees and then come back and write the final answer in radians. They are much more easier to work and think around. The person who posed the question, are you answered?
Yes, thank you.
Okay. Anyone else who has a question?
Yes, in algebra, page 30, D12.
30, D12.
Yes, under 2.4.5.
12. Prove that arc cos of negative x is equal to that. Okay, this is easy. D12, is it the one where they have arc cos of minus
Yes.
x equals pi
Yes,
minus
it's the one.
arc cos of x? So what I'm going to do is, do you remember what cos of, in fact, what I can do is to eliminate these things. I can just apply cos on both sides. So we can apply cos on both sides. So we now have cos of arc cos, which I'll write that way, equals on the other side, we have pi minus arc cos, which I'll write that way, of x. So what is the left-hand side going to be?
So why did you apply cos on other side and arc cos on other side?
It's because I can see I have coses, so I will, no, it shouldn't be a cos this side, it should be a straight cos, not that. Do you still have that question?
No.
Okay, yes, that arc was a negative there, was a mistake. And then the question is, what is arc cos? What is cos of arc cos of something?
Can you please repeat the question?
The question is, what is cos of arc cos of something?
Something.
It is that thing. So it should be minus x. Yes.
Minus that. And then the right-hand side, what is it going to be?
Pi minus arc cos x. I mean, yeah, arc cos x.
What do you mean?
I mean that we have I used the Cartesian plane because I know that cos exists in the first and the second quadrant. So the second quadrant is pi minus theta, and my theta is equal to arc cos of negative x. So I said pi minus.
On point. So what we should be doing here is, you should remember from back in the days, when you had 180 minus an angle, which quadrant would you think of?
Second.
Second quadrant.
Second quadrant when you see 180 minus something. So second quadrant. And what would be cos of 180 minus theta? What would it be equal to?
Negative cos
Minus
theta.
cos theta.
Yes, cos is negative on the second quadrant. So which means here, what we will have is negative cos of the angle, which is arc cos of x. And what is arc cos? What is cos of arc cos of x? you will see that it will be just whatever which is there, but when you multiply by the negative, it becomes that. So we are done. The person who posed the question, do you understand?
Yes, thank you.
Any other question? We delete the extra pages. Only one.
So on the same question, but take the 13, you do the same thing, applying tan on both sides.
On the same question, we see what you are saying.
But the 13, 2.4.5.
Yes, you would do the same thing and put in a tan.
Okay, thank you.
Any other question? We will share this PDF with you to go over, and then as questions arise, we will answer them in the group and as you get them. So for now, I think we can call it a day. Please go and practice and make sure that you do send.
So can I ask, will this video be available since I saw that it's being recorded? This
there to help, and your classmates are also there to help. Yes, it will be available for you to access to our deal. So you should go and out channel. Well, it's the last page. So you should go out on YouTube and check it out. The video will be up soon. So you should just go on YouTube and search. As you can see, you'll search SETMind. And then you'll check the video which was uploaded today. We'll upload it.
Thanks.
Any other questions? Okay, so the session was recorded. Please make sure you check it out on YouTube. It should be there after it's done processing. I can see someone has their hand up. You can go ahead. Student number what? 2852638.
No, I'm fine. Good. I'm good.
Okay, no problem. So practice so that you can have more questions. For now, take care and have a great night.